All right, so let's talk about 4.3 graphing radical functions. Radical functions as in roots. You've got a square root function, a cube root function, and these are their parent function graphs. The domain and range for your square root is different than the domain and range for the cube root. The square root has all the x's that are greater than or equal to 0. It does actually equal that 0.00, but nothing less than 0 is in my graph. And then for my range, all the y values also greater than or equal to 0. So nothing less than 0, though. I did not hit any negative y values. Now, the domain and range for your cube root function is all real numbers for both, meaning I do hit all positive, all negative x's. So my domain is all real numbers. I also hit all positive and all negative y values. So my range is all real numbers. All right, so this is my parent function. And I'm going to get some key points here, like the square root of 1 is 1, so it hits 0.11. The square root of 4 is 2, so there's the 0.42. And you can keep it going, like the square root of 9 is 3, so I can go 5, 6, 7, 8, 9, kind of off the chart here. Square root of 9 is 3, and it would continue going through these points. The cube root function, it's much more steep. The cube root of 0 is 0. Cube root of 1 is 1, but the next one would be the cube root of 8. So let's see, 4, 5, 6, 7, 8. Kind of off the chart here. Cube root of 8 is 2. So you can see it's kind of going in that direction there. And it does hit the negatives. Cube root of negative 1 is negative 1. Cube root of negative 8. So let's see, 5, 6, 7, 8. Again, kind of off the charts here. Square root of, or cube root of negative 8 is a negative 8. All right, so it would continue through that. All right, so the reason I bring up those 8 and negative 8 points is because it really could be a straight line if I just went through those other 3 points. The ones that are cube root of 8 and cube root of negative 8, those kind of help me see the curve. And let's see if we can graph the next few questions here. So number 1, graph each function below, then find the domain and range. So this one does have a few transformations going on. It's got the negative itself, which is a vertical reflection. So that's taking my square root function and it's making it come down here as my vertical reflection. And then the +2 on the x has to do with x's. It's going to be a horizontal translation. This will shift the entire graph to the left, or translate to the left by 2. All right, so again, it's like I go to the left 1, 2. All right, so it would hit that point. It's still like distance of 1, distance of 1. There should still be a distance of 1. Hit that next point. And so on. So let's see if I can plot these down here. So it went to the left by 2, okay. And it's that reflection. So like I said, it goes over 1. And then also the square root of 4 is 2. So if I went over 1, 2, 3, 4, I'm not going to go up. I'm going to go down by 2. And I could even keep going. We know the square root of 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If I keep doing this, I can keep it going, and it should look like this parent function with a reflection and shifted to the left by 2. Okay. So there is our f of x graph. The domain and range, domain has to do with the x's, range has to do with the y's. So it looks like my domain, the smallest x value it hits is over here at -2, and it hits everything to the right. So my domain is going to be all the x's that are greater than or equal to a -2. Instead of greater than or equal to 0, we shift it all to the left by 2. So greater than or equal to -2. The range, all the y values, those have to do with being below 0 right here. It used to be above, but now we are below 0. So I'm going to say all the y's that are less than or equal to 0, as opposed to greater than or equal to 0 on the parent function. Okay, so there's the domain and range. Number 2, this is a cube root function. I guess it didn't print out for you guys for some reason, so I just wrote that the function down. All right, so this is a cube root function of x plus 4 and then minus 1. It will have that plus 4, kind of like the plus 2 on the last one, where it was added to the x, so it shifts everything horizontally, either left or right. This one, because of a plus, we are shifting to the left. All right, shift to the left by 4. And then this minus 1, that's on the outside of your cube root, but it is still a shift of some kind, or a translation. You can call it translation, same thing. But it's going to go vertically. In our case, it will go down. Because of the subtraction, it will go down by 1. Okay, so let's take this cube root function that we have up here. I'm going to take those key points and I'm going to move them where we said we're going to move them. We're going to move left 4, so 1, 2, 3, 4, and down 1. Okay, left 1, 2, 3, 4, and down 1. Okay, all right. And then this guy left 1, 2, 3, 4, and down 1. Again, if I just stayed with those points, it would look like this straight line, but it's definitely not a straight line. It's got a curve. So I think I'm going to take this other point at 8. I'm going to go left 1, 2, 3, 4, and down 1. Okay, so it should have this kind of sharp curve here, and it would be similar on the other side as well. Okay, so let's plot these. -3, 0, -4, -1, -5, -2. Okay, and then the other one up here that we shifted was the 0.41. Okay, so let's see if we can get this curve going on. It's a pretty steep curve. It goes like this, and then it goes flat again. Okay. So there is our graph. And as far as the domain and range go, I did shift it up and down, left and right, but it's still going with those arrows on both sides. It's still going up and down forever, left and right forever. My domain and range are still all real numbers. There's actually an all real number symbol. You can write like that, or you could write out the words all real numbers. Same thing. All right. So then on your homework, it's also going to ask these kinds of questions where they give you this function. In our case, it's the square root of -3x. So it's your parent function for the following transformations. They want us to do a few things. They want us to, first of all, stretch by 5, and we'll do a translation up 1. So to have specifically a horizontal stretch by 5, horizontal has to do with the x's. And I'm gonna do pretty much the exact opposite. Usually when I multiply by 5, they get bigger, they stretch out, but I'm gonna do the exact opposite. I'm gonna multiply by 1/5 on my x. Again, horizontal has to do with the x's. So I'm gonna take my little parent function here. And I'm going to multiply my x by a, like I said, a 1/5. Okay. And then I need to shift the entire thing up 1 unit. Going up and down has to do with the y's, so it's not going to be on the x under my square root. It's actually going to be on the outside of the square root. It will shift up 1, so there's my +1. All right, I do have a little simplifying I can do. So the -3 times 1/5 is -3/5. Times that x, and then I got a +1 on the outside. All right, so here's the g of x function that we're going for. All right, and then number 4, we again need something horizontal, something that has to do with x's. Horizontal shrink by 4/5 instead of a horizontal stretch, but the same idea, it's got to go multiplied by the x. If it's horizontal, it's got to be multiplied by my x. Just make sure that you do kind of the exact opposite. I'm going to do, instead of 4/5, I'm going to do 5/4 to give me a horizontal shrink. And then my vertical, as in y values go vertically up and down, I want a vertical reflection, so I'll put the negative outside of my square root. Anything outside has to do with the y values. So it looks like I will get a negative outside of my square root, and I can simplify these guys. -3 times 5/4 So like negative 15 over 4. Still times x. Okay. All right. And then number 5 here, it says vertical stretch by 2. So again, I tried to color code that, the yellow stuff. Your vertical stuff, vertical stretch by 2, which means I'm going to put that 2 on the outside. And it'll still be a straight up 2. I'm not going to do the reciprocal or anything like that. I'm going to multiply by 2. And then the other one I want is a translation 6 units to the right. Translation, like shift the whole thing 6 units to the right. If I want to go to the right, usually my positives on my graph, positives go to the right, but with all the x's, I do the exact opposite. I'm actually going to put a negative. I'm going to subtract 6 from that x. Just from the x though. I wasn't subtracting it from the negative 3x. So I translated 6 units to the right, and I will simplify this a little bit. If I distribute my negative 3, that gives me a negative 3x plus 18 all under my square root. And I've got the 2 out front. Okay. And then last one here, write a rule for the function graphed below. So I can tell this is a cube root function just because I've got the arrows on both sides. So it's for sure a cube root. I think my parent function, though, was kind of facing the opposite direction. I think they did a reflection. So I'm going to put a negative in front of my cube root. Okay, so that took care of the direction now. But then I also noticed that usually my parent function, let's see, it hits these points, and then 6, 7, 8, cube root of 8 is 2. If I go to negative 8, I get a negative 2. Okay, so this is like my parent function. We already took care of the reflection. Also, though, this middle point, I think, has been shifted to the left by 1, 2. So if you're going horizontally, it should be with the x's. And so to shift 2 to the left, I'm going to put a plus 2 on my x to shift it 2 to the left. All right, and then let's see, usually it then hits, let's see, it goes like up 1 over 1 kind of. But if this is the middle, it didn't go up 1 over 1, it kind of went up 3 to go over 1. So let's see, going down, also went down 3 before it went to the right by 1. Okay, so I'm thinking they had a vertical stretch by 3. All the vertical stuff has to do with my y's, so I'm going to put that 3 out front. I still have the reflection, so I still need my negative. All right, so here's what we're going with, a negative, so a reflection, 3, so vertical stretch of my parent function, the cube root of x, and then the plus 2 means that I shifted everything to the left by 2. So here is the rule or the function. All right, there we go.